Hello all, this is Shweta Patel and today I'm going to explain about a topic called as sensors and actuators. Yes, so why sensors and actuators are needed in embedded system? Embedded system provides interaction with the real world. Embedded system monitors the real world depending on the changes in the world. So the changes which all are present in the world, maybe in terms of variables you can see them. These are to be sensed or detected and then any correction or monitoring or controlling operation to be done will be done by the embedded system. So sensing of these changes in the world can be done by using sensors and controlling or monitoring operation can be done by using the actuators. So an embedded system is in need of a sensor and an actuator, right? So if a embedded system is designed for controlling purpose, means I want to sense and I want to control it. If the embedded system is designed for controlling purpose, then changes will be done due to the sensed variables and these changes are now done by the actuator, right? Sensing is done by the sensor and these sensed variables will be changed accordingly and until it reaches the desired value, the functionality will be done and this is done by the actuator and sensors will be connected at the input side to the input port and actuators will be connected at the output side, that is through the output port. And that's why the controlling embedded system need to have both sensors and actuators. And if the embedded system is used for monitoring purpose, then actuator is not needed. Only sensing will be done and monitoring of those variables, how they are, how much they are increased or decreased, that monitoring only will be done. And that's why actuator doesn't play a role in an embedded system where only purpose is monitoring. That's why we need to know something about sensors and actuators, right? So now we'll discuss about what these sensors and actuators are along with the example. So what is sensor? Sensor, it is a transducer device that converts energy from one form to another form for any measurement or control purpose. It is nothing but it is performing some sensing operation. So what type of sensors we are seeing in our daily life? Maybe temperature sensor, it may be a moisture sensor, anything, right? So as an example, temperature sensor, what it does, it senses the temperature within that area and provides that information. So then what is actuator? It is a form of transducer device which converts signals to corresponding physical action. It is an output device. Now let's see some of the examples of sensors or actuators. Right. So at the first, let's discuss about LED. What is this LED? Light emitting diode. Right. It is used as an indicator for the status of various signals. So already you may have looked at different LEDs. Maybe in some buttons with power on or off indication. Right. Power on or off. Whether it is on or off, that is indicated by using an LED in your mobiles maybe or in any other device, whether battery is low, that is indicated by LEDs, whether it is charging or not, that is also indicated by the LED. So they are all I am making use of LEDs, right? So it is as shown in the figure. It is a PN junction diode. See, it will be having its own anode and cathode, right? See this, anode of the LED is connected to the supply voltage and cathode is connected to the ground, or anode can be connected to the positive of the supply voltage and it can be connected as to the negative terminal of the supply voltage, which is nothing but the ground, right? So the current flowing will be limited by connecting resistor in series between the power and the LED. You can see here we are having VCC, right? And this is anode. In between the two, I'm having resistor R which is connected. Why this is connected? In order to limit the current which is flowing within a LED, right? So LED can be interfaced to processor in two ways. It can be connected in two ways. Which are the two ways? In the first method, anode is directly connected to the port pin and its source current to LED when port pin is high. And the brightness of the LED is now directly connected to the current port pin sources. Whatever the port pin voltage is, depending on that, the brightness of the LED is decided. In the second method, cathode of LED is connected to port pin. What happens in the first method? Anode is directly connected to the port pin. But in second method, cathode is connected to the port pin and anode is connected to supply voltage. So LED turns on when port pin is low. Here brightness of the LED depends on the supply voltage. Thus, when current flows, light gets emitted. That's why the name is LED. So this is all about LED. Okay. Then we have to explain some application of LED where I'm using is 7-segment display. 7-segment LED display I can say, right? You can see here this is a 7-segment display, right? It will be as shown in the figure. It is also again an output device. It is used for displaying alphanumeric characters. It contains 8 segments. You can look at how many segments are there. A, B, C, D, E, F, G. You may be wondering where the 8th segment is. Here are the 7 segments. What are they? A, B, C, D, E, F, G. And one more is here, that is DP. Fine. What is this DP stands for? Decimal point. So I'm having 8 segments in total, 7 for displaying alphanumeric characters and 1 for representing decimal point. The segments are named as A to G and decimal point is named as DP. You can see here. Okay. So depending on what is to be displayed, we are now providing lit to A to G and DP. What it means? Assume I want to display 4. I want to display 4. How can I write 4? See, this, right? So what is to be done? F, G, B and C are used along with DP, right? So in order to have a display as 4, the segments F, G, B, C and DP are lit. So in order to lit these, we have 2 configurations. We have 2 configurations for 7-segment display. You can see in the figure. See, in this figure, we are having 2 configurations. What is shown here? One is common anode LED display and one more is common cathode LED display. Isn't it? So, in common anode configuration, the anode of the 8 segments are connected common. See here, in the figure you can look at all these. What are these? A to DP means 8 segments. The anode of all those are connected in common. Right. So you can see here also common cathode LED display. What happens? All the cathodes, all these are cathodes, right? So all 8 segments cathodes are connected in common. So in common anode configuration, the anode of 8 segments are connected commonly. Fine, as you can see. Then all anodes are connected commonly and in common cathode, all cathodes are connected commonly. What happens to common anode? How will it display? As we all know, anodes are connected commonly. But what happens to the cathode? The cathode of LED segment is connected to logic 0. If whatever I want to display, depending on that, in order to display 4, what we did is F, G, B, C and DP are to be lit, right? So to all these, I'll be connecting to logic 0. All these segments are connected to logic 0 and all anodes are connected common, right? Then I can have a display as 4. Likewise, all these segments will be connected to logic 0, where in common anode. What happens in common cathode? In common cathode, all cathodes are connected commonly. And depending on the number to be displayed, the anode of the segment is to be connected to 5 volts. You just have to remember, here I am connecting all these. See, in common cathode, these all I am connected to supply plus 5 volt. But what happens in common anode? All these cathodes I am connecting to 0, logic 0. Here logic 0 in common anode. In common cathode, I am connecting these to 5 volts, that is supply voltage. This is how 7-segment LED display works. Right. Next let us discuss about optocouplers. The name itself is telling it is a coupler. You can see here, this is the diagram wherein I am making use of two optocouplers. See, this is one optocoupler, this is one more optocoupler, right? So it is a solid state device which is used to couple parts of a circuit. So I'm having one more called as opto isolator. The same will be there, which is isolating the two things, right? In optocouplers, what it does, it combines LED and phototransistor in a single package. You can see here, this is an LED, this is a transistor, phototransistor, which is coupled within a single, right, single package. These can be used in input circuits or output circuits. These are available as ICs. So coupler is one which couples two devices. Okay. Then moving to relay. Next type, that is delay. This is an electromechanical device. These contain a relay coil. Fine. It works on electromagnetic principle. Means when voltage is connected to the relay coil, current starts to flow through the coil. This current generates a magnetic field. This magnetic field which is generated, it attracts the armature core and moves the contact point. This changes the flow path. Relay is having some configurations. As you can look here, they are having different configurations for the relay. The first configuration is single pole, single throw, normally open. The other is single pole, single throw, normally closed. And third one is single pole, double throw. Okay. So we have to take a glance on all these, right? So as we can know, single pole, single throw is common in the two. First one is normally open and second one is normally closed, right? So the path, it is having a single path. By single pole name, we'll come to know that it is having a single path, right? So single path will be there for information flow. The path may be either open or closed. For normally open, this is single pole, single throw, normally open. For this, what happens is, for normally open, we'll have the circuit which is open normally and it becomes closed when relay is energized. But for normally closed relay, circuit will be closed. Normally circuit will be closed and it becomes open when relay is energized. Okay. Moving to the third, that is single pole double throw relay, which has two paths for information flow. In the first two categories, I am having only single path for the information flow. But in the third category, we are having two paths for information flow, and those can be selected by energizing or de-energizing the relay. Okay. So this is all about how we are configuring the relays. Now let's move to the next one called as piezo buzzer. Okay. So this is a piezoelectric device. It generates audio indications in embedded applications. When voltage is applied to the circuit diaphragm, and piezo buzzer produces audible sound. These are available in two types. One is self-driving and other is external driving. Self-driving generates a tone on applying voltage, but external driving buzzers generate different tones by applying variable pulse to buzzers. Okay. Next, let's move to push button switch. It is an input device. It also again is having two configurations: push to make and push to break. That means in order to make the connection, we have to push in the first category. In the second category, what happens? In order to make the connection, we have to, in order to break the connection, we have to push. So in push to make configuration, switch is normally open and it makes circuit contact when button is pushed. Okay, that is why it is push to make. In push to break, what happens? Switch is normally closed and it breaks contact when pushed. Okay, so this can be shown in the diagram. So this is all about push button. So these are some of the actuators and sensors which are used in the embedded systems. Right? So we can now, in the next video, can discuss about some other actuators and sensors. Thank you.